So hopefully we don't have computer crashing problems today. So we're taking a look at the flight path of a baseball, that is, in the flight path is described by h height is equal to -16 times t squared plus 48t plus 8. And we're asked to find the maximum. And for this question, you really need to use a graphing calculator because this is a prime equation. You cannot factor it. Now, in April, we'll look at ways to solve this problem and get answers without factoring, but we're not there yet. So I'm going to go to my graphing calculator, my web-based graphing calculator. It's accessible straight off the 8th grade site. And I'm going to type in the equation into the equation bar. And then I'm going to hit my graph, and I will get a graph. And I can see that the maximum point occurs right about here. But I don't want to estimate it by the graph, so really I want to look at the table. So I'm taking a look at the table. And so I can see here that we have a starting value of -7, which means 7 seconds before the ball was hit. And that doesn't make a whole lot of sense in the context of this problem. So I'm going to change that to 0 seconds. And then if I look at over here, after 20 seconds, the ball will be almost a mile underground. Well, I know that's not going to happen, so I'm going to switch my interval of x to 0.1, 1/10. And let's see if I get something that makes a little more sense. Oh, yes. After 2 seconds, that's at about 40 feet. So I'm going to, right now, well, let's look at the maximum. So what number is the largest? Number 40, so they're getting bigger. Then now they're getting smaller again. So at 1.5 seconds, I have a maximum height of 44 feet. That's my maximum. So now I want to see when the ball hits the ground, so I'm going to go to an interval of 0.2. So I get more, oops, we have that extra decimal there. And so now, okay, so at 4 seconds, in theory, it'd be underground by 56 feet. I know that's not going to happen. And at 3 seconds, it's back at 8 feet, which is where it started. So it's going to hit the ground somewhere between 3 seconds and 3.2 seconds. So I'd say 3.1 seconds it'll hit the ground. So let's go back to the problem. And my daughter stole my pen out of my pocket. Thank you very much. So what is the maximum height? We said it was at 1.5 comma 44, I believe. If I miswrote that, I'm sorry. You can look back at the table. When does the ball, when does it hit the ground? We said it hits the ground at 3.1 seconds. And then the pattern of change, well, obviously it's a parabola. And then what does the 8 mean in this context? This means that the ball was let go at 8 feet above the ground. That is pretty high. So this baseball player must have been at least 6 feet tall, throwing with the ball way over his head, minimum. But even still, that seems a little high. But that's the way it goes in this equation. So that is how to do problem number 6.